In this video on geometry of straight lines for grade 9, we're going to have a look at some advanced examples. Example 1. Determine the value of A, B, and C in the given sketch. We are given that there are two pairs of parallel lines. And when we start to determine the value of A, you will see that A is part of two of the angles in our sketch. And these two angles form an F, which means that the corresponding angles are equal in size. So the angle 3A plus 30 degrees should be the same size as the angle 6A minus 60 degrees, because there are corresponding angles, and in this case we use the parallel lines EF parallel to GH. If we now want to solve A, we need to get all the variables on the same side, so I'm going to take all of them to the right by subtracting the 3A. Next, I'm going to take all the constants to the left-hand side, which means I will add the 60 degrees that's subtracted on the right. This means that 90 degrees will be equal to 3 times A. If I now divide both sides by 3, A is 30 degrees. Next, if we want to determine the value of B, there's more than one option. Firstly, you could have recognized that angle B is formed by two straight lines intersecting, which means we have vertically opposite angles that should be equal in size. Or you could have recognized that angle B is the alternate angle for the angle 3A plus 30. I'm choosing to go with the angle B should be exactly 6A minus 60 because they are vertically opposite angles. We just calculated that A is 30 degrees, so we can now substitute A with 30 degrees. This means that we have 6 times 30, which is 180 degrees, and if I subtract 60 from that, B will be 120 degrees. Lastly, if we then move on to angle C, you will realize that it forms a U with angle B. This means that C plus the 120 degrees from angle B should be equal to 180 degrees because they are co-interior angles, and here we used parallel lines AB and CD. So angle C is 60 degrees. Before we have a look at the next example, it is important for you to realize that theorems also have inverses. Any theorem consists of an if and a then part. If we know something for a fact, we can use it to make a conclusion or deduction. As an example, we're going to have a look at parallel lines. If we know the lines are parallel, we can make the conclusion that the corresponding angles will be equal. We can also say that the alternate angles will be equal and the co-interior angles add up to 180 degrees. The if and then parts of each of these three theorems can now also be swapped around. So, if we know that the corresponding angles are equal, we can make the conclusion that the lines are parallel. Similarly, if the alternate angles are equal, then the lines are parallel, and if the two corresponding angles add up to 180, the lines are also parallel. Let's go and have a look at the example. Example 2. In the sketch, angle B is 30 degrees, and this is already indicated on the sketch. Next, they say that angle BCE is 150 degrees, which means that C1 plus C2 add up to 150. We are also given that angle E is 60 degrees, and they mention that line AB is parallel to line CD. The question: prove that CD is also parallel to EF. To prove that two lines are parallel, we're going to make use of one of our inverses or converse theorems. We can start off by determining all the angles by using our given information. We know that AB is parallel to CD, so we can use alternate angles to say that angle C1 is also 30 degrees. And because we know that the whole angle C1 plus 2 equals 150, we can now make the conclusion that angle C2 is 120 degrees. If we now focus on the two lines that we need to prove are parallel, you will see that we can form the U. And without using the fact that the lines are parallel, we can still say that these two co-interior angles add up to 180 degrees. And with our converse theorem, we can now make the conclusion that the two lines are parallel. Now we need to be able to write this whole process down systematically. We started off saying that angle C1 is equal to angle B, which is 30 degrees, because they are alternate angles, and we used the parallel lines AB parallel to CD. Next, we make a conclusion because we know that C1 plus C2 should equal 150 degrees, which was given to us, and we know that C1 is 30 degrees. We can say that angle C2 is 120 degrees. If you wanted to supply a reason for this, it is simply that it was given information. Now we can move on to our purple part. We know that angle C2 and angle E, when added up, is 120 plus 60 degrees, and that gives us 180 degrees. For this, we don't need to supply a reason because we simply added up two angles. But from this 180 degrees, we can now make the conclusion that the two lines CD and EF are parallel. And the reason for this is because the co-interior angles add up to 180 degrees.